Hey guys, I wanted to take a moment here in this video to talk about where we get this formula for the area of a triangle. 1/2 base times height, or base times height divided by 2. Hopefully we already understand how to find the area of a rectangle. The area of a rectangle can always be found by multiplying its base times its height. So this would be 3 times 4, giving us an area of 12. You can even see that with the little squares inside. If we count all these up, we have 12 squares. But how does that help us find the area of a triangle? Well, this triangle has a base of 3 and a height of 4. Same as this rectangle. So when we multiply it by 1/2, that means that this triangle should be exactly 1/2 the area of this rectangle. And if we kind of drag that over, we can see that, yes, indeed, this right triangle is exactly 1/2 the area of this rectangle. So with a right triangle, pretty easy to see how that works. This would be an area of 6. 3 times 4 is 12, times 1/2 is 6. Let's look at a different triangle and see how this might also apply. Now, here we have an acute triangle. There is not a right angle in our triangle, but we do have the height drawn in at a 90 degree. So this triangle is still a base of 3 and a height of 4, so it should have the same area as the last one. And we have the same rectangle that we had in the previous example. This rectangle has an area of 12 as well. 3 times 4 is 12. And when we superimpose it, when we move it over on top of the other one, you can see maybe that this triangle is half the size of the other one. What you want to focus on here is two smaller rectangles. So this rectangle right here, and how that is being cut in half by this part of my triangle. So this part of my triangle is half of that rectangle, and then this little skinny side over here, how that is being cut in half right there. And so this part of my triangle is half of that rectangle. So overall, this triangle is still half the size of this rectangle, just a little bit more complicated. And finally, let's look at another example. This one's the weirdest. So we have this obtuse triangle. You can see this angle here is much greater than 90 degrees. When we have that, sometimes the height actually has to be drawn externally on the outside of the triangle. And you have to sort of extend one of the bases out so that you can draw a 90-degree angle to the base. In this case, if I were to just drag this rectangle over, which is again the same size as our previous example, it's 3 by 4, and this triangle should be the same area as our previous examples, 3 of a base of 3 and a height of 4 should have the same area. But it's a lot trickier to see that this triangle is exactly half of that rectangle. And this is where I'm going to leave this. I actually have a link to a pretty cool video that I'll put down in the description that shows how this obtuse triangle actually still follows the same formula. Hope you'll enjoy it.